Okay, so last but not least, we have our last point today. It's from Michaela, the CEO of Jaspero and Splendid IT. So today's topic is about statistics on the test and experience with companies with too few tests. So also pretty interesting topic. And also I think Michaela will do it more also very interactive. So I'm looking forward to all the questions and your participation also in that talk. So Michaela, it's your stage.
Thank you. So as I'm no technician and I already know that it's late and all of you had a full head of interesting topics from the technicians before, I will keep you listening with, please install in the meantime Kahoot ID. I will ask you some questions, 5 questions over the whole talk, and the one who wins it will get the full license of Jaspero. So I know that Ardit's talk is not too top, but I'll try with my Kahoot. So as a little bit later, I will share the screen with the gaming ID. But first of all, I give you the time to install Kahoot on probably your mobile or PC if you want to share screen. But now I will.
But I think it's only opening, right? And then you get the game pin and then you enter it.
I hand you over the game pin, but as you first will install it, then I will try to do my best in what all I have opened already with my talk. And one moment, I will probably do my talk first. Yeah, okay, share screen. So can you see my test figures?
Yes, we do.
Okay, then I will start. Quick. My name is Michaela Prehofer. I'm, as Tom already told you, I'm CEO at Splendid and a product owner at Jaspero. But one thing describes me most, I'm a quality enthusiast. I did a lot of courses to ensure quality in the projects, in the processes, and in the software development. Software quality is something which is really most important for me, and software test is only a part of it. So I want to go deeper in the topic, how to explain software tests. Software tests has a lot of descriptions. I took 2 of them. I took the one from IBM, which explains that software test should verify whether the software developed and makes the same result than you already planned to have. But I prefer the one from Guru 99, which is that it's a method, that you should do it methodically, and you can do it manually or automatically, but you should do it methodically, and you should identify errors, gaps, and missing requirements, not only compare outputs with the planned output. So it's really much more describing what testing, under my opinion, is. So then now we should go to the next screen. Sorry for that, but we go to Kahoot right now. Let's see. A quiz. Which standard regulates software testing? Okay. And this is correct. I will share now back to my Bildschirm Java Refactoring. You see the answer? The standard ISO 29119 substitutes all the other ones. The other ones are sub-topics of the new standard, and they only have parts of it. So the answer was correct for most of you. As Reinhard already showed you in the first talk, there are a lot of testings. I listed you on the page of Guru 99, who lists 100 different types of tests. So if someone wants to test all parts of his software with all test methods, then he can look there and get an impression of it. But I think you can focus on functional, non-functional, and maintenance tests with the tests above, like unit tests, smoke tests, user acceptance tests, integration tests, and so on, which are all listed here. And in my experience, most companies focus on unit tests and regression tests and also on integration tests. Acceptance tests are my experience, the most difficult tests, because acceptance tests are defined normally at the very beginning when users describe their needs for the new software development and also what have to be provided from the development. In the end, you do the acceptance tests. I hope they don't fail and everything's fine. But then you have to discuss with the business units to sign them. And testing is not only a technical stuff. Testing is also a stuff of a discussion of definition and accepting the results. And acceptance tests has to be defined and accepted from the business units too, and they have to sign at the end that they got what they ordered. That's not so easy. So you can compare unit tests, result described, and the results you have gotten from after the tests. But if you don't get the signed acceptance test, the delivery is not correct. So how to write functional tests? Functional tests seems to be very easy. You identify the test input, you describe how to compute the tests, how to maybe also the environment and the data you need and the preconditions and the past conditions. Then you execute tests and then you compare the results. And this is an iteration of many cycles. All the time you change your software. It seems to be very easy, but why companies are not doing it that often? Because time. They forget that testing ensures the business output. And later on, you will see that there are big losses because of not executed software tests. I will show you the 12 most costable failures in software development, and some of them costed life. So that's really expensive. Yeah, as we already had, here's a short description, and as I have to hurry a little bit, I will skip that. You can read it afterwards. You will get the slides. And then we will go to the second question. Oh, now we see the ranking. SASE was the fastest. So it's not only the correct answer, it's also the speed. So you have to hurry up if you want to win. So the next one is a puzzle. Please set the 4 steps of the software testing process in the correct order. The correct order is, as you see, test scenario, test case, test execution, and test result. So let's go to my screen and look a little bit. As you see here, first of all, you have to plan the test scenario, describe the functionality you want to test, the environment you want to test, and the features has to be described with the test. Then the test case, of course, has to be written, then test execution and test result. But as you have been that fast, I'm quite sure that it will be no problem. So let's see who is the winner. Let's see. SASE is still the fastest, even if you guess. Marcus is second place. Tom, there is no answer from you.
I was wondering. Actually.
Me too.
I also gave an answer. But either way, Michi, I don't think that I will win.
No, not if SASE is together. So what is the difference between functional testing in the normal software process and HL processing? HL processing does not, at the beginning, you don't have all the functionality described and or written down. And so it seems that it is not necessary to test, but that's not true. HL testing is a core part of the HL software development, and as you can read all the other descriptions, I will ask you the next questions because I have 7 minutes left. So next question: true or false? As the HL testing has an HL manifest, is testing a part of the HL manifest? Answers. Let's see how it changes. SASE is still leading. Then I will go to my back and explain you why it is not. I copied the core parts of the HL manifest here. It's small, but I hope you can read it. If you look in it, test is no part of it. The HR manifest is 20 years old right now, so it has birthday this year. It's written 2001, and the highest priority is the first sentence. Our highest priority is to satisfy the customer through early and continuous delivery of valuable software. Of course, valuable software cannot be reached without testing, but testing itself is in no way part of the manifest. So, but there are a lot of test methods which are described in HR methods. Test-driven development, acceptance test-driven development, pretty well known, I think, to every developer. You write first a test and then develop and look whether the software you have written is also performing as you thought. Acceptance test-driven development is a little bit more difficult because you don't define the test yourself. You ask the customer for the test cases and develop what the customer in the first step defines with you. I think this is the most important test because who else than the customer knows what he needs in the software if you're not in an experimental programming or in a completely new topic of developing and research. Yes, of course, behavior-driven development defines the functionality and not the test case itself. Not that much known is exploratory testing and session-based testing because these tests are not really written at the beginning of the tests. You normally do them if you have software already written or maybe already in use where you don't have enough test cases or you don't know the behavior in detail. It's a little bit like learning and developing at the same time because you write test cases, document them pretty well, and in the end know more about the functionality, the output, and the behavior of the program you want to maintain probably. It's hard to do so, and I think I don't wish anyone to have no documented software, but as we are legacy experts, we know that this is very often, and this test methods helps you to get a little bit deeper in the software sources, not by learning the sources, reading the sources, by testing it, and by session testing, like focus on special functionality or behavior parts and test it iterative and find out what your program is doing and then document it pretty well. So what are the best practices to test cases? We heard a little bit about this, but first of all, a test should be simple. You shouldn't write that complex tests that you're not able to follow them after some time. A test case should have one expected result, not several ones. It can have some previous data you need or some preconditions, and you can describe very exact how you should run it, but it should have at least only one really valid result. It can also have both conditions, but one result. Create tests for the end users. So don't sit down and think about some theoretical test cases. Think about your customer needs, as we have seen in the HR manifest. We write software for the users and not for a self-fulfilling work. It's for users to think what they need. Avoid repetition. As we heard before, there are a lot of corner cases you have to take aware of, and you have to test them, but don't make repetitive testing with unnecessary test cases. They do the same and have maybe another result because the calculation is different, but the real result, testing the functionality and testing whether the software is working as expected, is the same. Ensure 100% coverage. So that's fine to read, but I think in most cases it's not possible, and you should at least have 50 to 80% test coverage in most cases. Identifiable seems like, what do we mean with it? Don't write names for your test cases. Use case IDs, test case IDs, list the tests correct, have a test catalog written down, and identify all your tests, describe them, and so you can really see which test failed. And if you repeat them, you use the test ID and not a written name, you don't use that. Yes, use known test techniques. Tests should be repeatable, and if you do a test for one time, think about setting it up repeatable for several times, especially for integration, regression tests, or if you change or maintain the software, they should be repeatable. If the test resources allow it, peer review your tests. Oh, I have the next question for you. So let's go. Next. A quiz. So if testing is a lot of a lot of work, how many test lines of code an average programmer writes per year? Oh, the correct answer is less than 10,000 lines of code per year. That's not from me. There is an Dison writes that there is a programmer productivity paradoxon, and Carpus-Jones evaluated different kinds of software development methodologies and found out that the normal programmer writes per month 325 to 750 lines of code per month. So it's not that much as we think. It's less than 10,000 a year. So there is no reason to test them proper. So, and if you see that they say that they have 200 lines of code, getting the cost of bug fixing is not that easy to find in the internet. Google made a research on it, and Google and IBM are the only companies who also publish their results. So the costs of bug fixing are normally, if you follow the calculation, 40% of software development process is bug fixing. So if you start bug fixing earlier, the research of IBM shows you that as early as you find the bug and start testing, the costs can decrease really enormously. If you found the bug, it's not a bug, it's a not missing requirement in the requirement phase already, then a bug costs you 100 euro. If you take the requirements, make unit tests or whatever tests you implement and develop them, and a bug occurs then, it costs $1,500. But if you don't find the test and the customer finds the test because it's already productive, then each bug costs more than $10,000. That's a statistic from IBM, as there are not a lot of other statistics, we have to believe them. And there is also one interesting statistic about the cost of software failures in 2016. Later on, I have also some nice literature for 2020 already. Cost of software failure costs $1.1 trillion in the US per year in 2016. So it's an enormous amount companies lose in not testing or in don't set up methods to find the bugs during an early stage. Because if you look here to the calculation of Google, the unit tests costs approximately €5. If you compare it to the costs of $10,000 per bug you only notice during the already running system, I think there's a big difference. So please invest a little bit more time and money also in software testing, more than 10 to 30%, like usually. So we are going to the fifth question. Let's see, next question. Oh, Reinhard is first right now. So Sazi, do your best. What are the most expensive software bugs in history? Oh, we have one answer more than right now. I'm quite happy for that. The Y2K bug seems to be the most expensive test if we only take tests with a manual, with a money effective ones. As you see, I have a list of software bugs, and under my opinion, the most important bug is the first one, where a software bug was due to a software bug, the software was unable to defend from the enemy, and 28 soldiers died. So you cannot monetize this software bug, but it's the most important for me. The second one is a PayPal error, which has been solved within a very, very short reaction time. So that's why it is not in the most famous and most important bug list. But Chris Reynolds was for a few moments the most richest person on the world. He had an amount of $92 quadrillion on his account. It was rebooked, so some minutes later he has the same account than before. The Y2K bug indeed was the most expensive bug ever. I think every one of you knows the Y2K bug, where you cannot solve problems over the 2000 year. So all companies with systems, with older systems, have to change, and it was quite very expensive. And in the end, everyone now is surprised why years are only 2 digits and not 4, but it was like that. Here, one of the software bugs with the most impacted person is the child support system, where the integration test failed, and the changes in 2 systems lead that more than 239,000 people could not get the child money in the UK, and it was not the big amount. It was the cases which have been affected by these software bugs. In the end, 36,000 people have been affected. After solving the problem, they have to be corrected manually. So the other ones are, a lot of them are a Bitcoin hack. Someone lost 850,000 Bitcoins. Of course, if there is a bug in aerospace, then many people are affected. You see, there are very much costs on that. And one of them is also very interesting. It's the Morris worm. It's a worm who affected really big systems and spread it over worldwide. And it was the test of a student. It was not being thought at the worm itself. It was a test, and it affected really big companies too. And there are also some topics which are not figured out, like there are right now. You see the Heathrow Terminal 5. I don't know. I think every one of you remembers the opening of Heathrow Terminal 5, and they tested it pretty well. And when they started with day 1, the luggage couldn't be put into the right airplane, and they had to cancel more than 500 flights. One of the strategic bugs is also the explosion of gas pipeline in the Soviet Union. They discussed whether there was a hack from US, or maybe a worm from US, or CIA wanted to get the knowledge of the Russian pipelines. So there is a big software bug, and the pipeline exploded. So this has no monetary figures, but it's a big output of this bug is not only the explosion, also the subject of environment and everything else. So the last sentence is, I recommended you some literature. As I said, that the figures, not the biggest software bugs, but the figures for the cost of software bugs in execution is very high. There is a new research from CISC. They are free for download. You can only you have only put in your data and you get them. And I really recommend you to read them, how important it is to maintain it, to also maintain legacy systems, to test them proper, and how enormous costs can arise if you don't look for proper software quality and testing. So, as we already know the winner, let's go back to Kahoot. Let's see the next winner. The winner is podium. Oh, Marcos. So Marcos, you won. No, you're third. Sazi is 3 of 5. Oh, that's cheating. Reinhard will get Reinhard has 4 of 5 correct. Sazi 3 of 5, but was faster than Marcos. So I'm quite happy. So many correct answers. I'm happy that not 5 of 5 questions are correct. So my questions have been a little bit tricky. So thank you for your attention. If you have some questions right now, I will answer them. But I have also difficult questions to see.
So I think Michaela, we will give the free license to Marcus.
Of course we will.
Yeah, we do, sure.
So I will stop right now. My share, screen share.
Any questions to Michaela?
Oh, as I see
yeah,
that.
I wanted to say something, but more just a statement than a question, because with all those critical systems, I think the formal software verification should actually be considered more often. I think there is still research going on that direction, but for critical systems, which is practically impossible to cover 100%, I think having a look at the formal verification is the only way to go, so that we don't have next time planes crashing or processors failures or similar bugs that cost lives or billions of dollars. And it's in practice, it's impossible to be covered basically, because there are infinitely many, practically infinitely many test cases that one would have to write or generate, which would take enormous amount of time and resources that cannot actually be reached in today's technology.
Yeah, I'm so happy that Evelyn showed us the automatical test case generation today, and I hope that the progress in this tool will be quite fast, because there is a big necessity, not only because of the monetary effects of a bug. It can cost life, it can pollute environment. It's very critical testing less than necessary. So
perfect.
Okay, yeah, as there are no other questions. I'm used that the technicians skip my talks, but I think it's necessary to tell them how important tests are. Thanks.
Yeah, the quiz was perfect.
Okay.
I think I will just stop